Hi, everyone. So this is the second module for the BioC32 short communications assignment. And as you can see, this module is about research questions. So I want to begin this module with a question, and that is, what is the purpose of scientific research? Why are there so many women and men around the world engaged in this activity of doing scientific research? And I actually think the answer to this question is fairly self-evident. It's to expand human knowledge of the universe, right? As humans, we are a very curious species. We want to know everything there is to know about everything. And that really, in my mind at least, is the reason that scientific research exists. It's a way of trying to help us to expand our knowledge of the universe. Now, a follow-up question to this perhaps is, well, why are we so interested in knowing everything about everything? And I think there are two reasons for that. One is just for its own sake, right? Knowledge for the sake of knowledge. And the second reason is to benefit humanity. That ideally, the more we know and understand the universe, the more that we can ensure that as humans, we're going to live good lives and have a great environment that we can live in. Of course, you can probably think of examples where scientific research has actually been to the detriment of humanity. If you think about things like atomic bombs and maybe chemical warfare or something like that. But I think that this is the two fundamental reasons why the vast majority of people engage in scientific research. They want to know for the sake of knowing, and they want to learn for the sake of trying to benefit humanity. Now, these two reasons for doing scientific research, these two reasons for trying to expand human knowledge, they lead to two very different types of scientific research that people can engage in. One is called basic or blue sky research. So basic research is basically research for the sake of just knowing more information. So this is where researchers will just kind of ask questions driven by their curiosity, and they'll perform experiments and see what kind of information they're able to gather. We sometimes call this blue sky research because if you think about the beautiful blue sky, which we've actually seen too much of this summer, we could use some rain, in fact, some gray sky. But when you think about the blue sky, it feels like this limitless place. And so basic research is sort of a type of research that has really no limits. You can ask any question you want to ask and try to explore and answer it. On the other side, we have what's called applied research. And this is where you're trying to do research to actually come up with something that's going to directly benefit humanity. So some kind of new drug, some kind of new technology, for example. So, there are these two different kinds of scientific research that people can do, and obviously they are related to each other because really it's basic research that ultimately leads to applied research. You can't do applied research unless somebody else is doing basic research. Basic research kind of, accidentally in many cases stumbles upon interesting discoveries, and then applied research kind of takes that interesting discovery and tries to translate it into something that would actually be useful in some context. Now, what's interesting, of course, is that when we think about the Canadian context for research, most scientific research is funded by these big taxpayer-funded agencies. So I highlight a couple of them here. One is NSERC, which is the Natural Sciences and Engineering Research Council of Canada. The other is CIHR, which is the Canadian Institutes for Health Research. Both these kind of granting agencies, these funding agencies, will provide researchers in Canada with money to do research that would be either basic or applied research, and generally would fall under the heading of human physiology research, which of course is what we're going to focus on here in this course. So we have a bit of a sense now of why we do research. We have a little bit of a sense now of who generally pays for research. And as we start trying to transition into the sort of how do we do research, I want to share with you this quote from a paper by Haynes et al. They said here, a scientific researcher must know where the boundary between current knowledge and ignorance lies. So if we're going to expand human knowledge of the universe, we have to first of all know, well, where is the current boundary of our knowledge, right? Where is that boundary between what we currently know and what we currently don't know? That's the territory that we as scientific researchers want to kind of claim a stake to, that boundary between the known and the unknown. I don't know if you've ever maybe been traveling somewhere, maybe around your neighborhood, and you get to a part of your neighborhood where you think, hey, I've never been down that street before. I know these streets over here where I just came from, but if I cross the intersection and go over to that area, it's a totally new area. It's kind of a thrilling space to be, right? Because you say, okay, well, I'll cross the road, I'll go over into this unknown space, and I have no idea what I'm going to find there, right? There's a little bit of a thrill and excitement that comes with exploring some new territory. So that's the way a lot of scientific researchers feel. They feel like they are charting unexplored territory and trying to learn new things and then take that information back. Maybe you go and explore this new area of your town that you've never been to before, and then you go back home and you say, hey mom, or hey sis, or hey grandma, or whoever, did you know if you cross the intersection at such and such a street, there's actually like a graveyard back in there, or whatever. Like, you bring that information back and you share it with others. Like, that's the kind of really cool feeling that I hope you're going to experience as you are going through this short communications assignment, especially and that journey begins here, I guess, with coming up with some good research questions. Anyways, one of the things I also wanted to do at this part of the module presentation is to also acknowledge that being on this boundary between current knowledge and ignorance, and trying to come up with some research questions so you can kind of explore what we don't know and try to create new human knowledge, that's also a very challenging and daunting task as well, right? And I'll tell you a bit of a story here that will hopefully make you feel a little bit better about any struggles that you might face here as you're trying to kind of come up with your own research questions. When I was a postdoctoral researcher, so what that means is I already had completed my PhD, and now I was working kind of as an independent researcher. I had a supervisor and was kind of working towards building my own independent research program. And when you're a postdoctoral fellow, not only are you trying to build your own independent research program, but you're also searching for research faculty positions. You're trying to find a long-term job somewhere. And I actually interviewed at quite a few different institutions, and basically went to these places and kind of pitched to them, this is the kind of research I'm going to do if you hire me as a faculty member here. And I didn't get any of those jobs as a research faculty. I'm here at UTSC as a teaching faculty, not a research faculty, but I didn't get any of those jobs at the institutions where I applied as a research faculty. And the reason for that, I've realized in hindsight, is because even though I was a postdoctoral researcher, so even though I had been through 2 years of a master's degree, of course that followed my 4 years of undergrad, I'd been through 4 years of a PhD, I'd been through 10 years of post-secondary education by the time I was applying to all of these jobs. I still was not very good at coming up with interesting, novel, and relevant research questions. In many cases, I was going to these interviews, I was basically, pitching that I was going to do something very similar to what my PhD and postdoctoral supervisor have been doing, but maybe with a slightly different animal species, or whatever the case might be. So, I realize in retrospect that, I didn't have any great research questions. And now it's totally different. Here I am 12 or 13 years out from my postdoc, and again, I don't do a huge amount of research here at UTSC. I do take on a few undergrads every year, and we do a little bit of plant-based research up in the greenhouse and the science wing. But now, I've got all kinds of questions, and I have no problem coming up with interesting and novel and relevant research questions. So, I guess the point I'm trying to make here is that, don't feel bad if you're struggling to come up with a good research question. It's definitely something that gets easier and easier with experience, but we have to start somewhere. And that's why we're having you do this here in this third year human physiology course. If you start working on the process of coming up with good research questions now, hopefully you'll be able to do it better than I was able to do it when I got to my postdoc. Maybe if you go into grad school, your master's, your PhD, whatever, because you've had a bit of a head start in terms of trying to derive interesting and novel research questions, you'll be ahead of where I was in my scientific career. In any case, let's dive in now to really the nuts and bolts of how does one come up with a research question. I've just sort of said it can be a challenging thing to do. What I'm going to advise here is that the place to start is to just come up with any question that interests you. Okay, this is where I would start. Okay, and I say this because this short communications assignment is way more fun when you're doing research on a topic, a question that really is of interest to you, right? So if you come up with like a really boring question, one that you're just not excited about, even if it's novel and relevant, if it's not interesting to you, it's not really a question worth exploring, right? Like you're going to spend a good chunk of time here in this assignment, in this course, trying to answer this question. So if it's not a question that excites you, it really can be hard to be motivated. But if it's a question that excites you, then that's what sustains you, right? You're like, I really want to know how this is all going to turn out. I really want to know what the answer to this question is going to be when we do this research, and that'll kind of drive you through. Now, I also have to acknowledge here that you're working on this assignment as part of a group, right? So there's going to be 3 or 4 or 5 of you in a group together doing this assignment, and you're possibly all going to have different interests. So it can also be a little bit challenging sometimes to find a question that is of interest to everyone. So do your best in that regard, but you do have to recognize that not everyone might be able to get a question. Your group might not be able to come up with a question that everyone is thrilled about. That's okay too, right? I remember getting some great advice from an undergraduate research supervisor that I worked with for a couple of years. She said to me that if you're a true scientist, you can get excited about anything, right? And I've come to experience that in my own life, right? That you start doing a research project, and initially you think, I'm not really super excited about this. But then as you start to learn more and more and more, you start to think, oh, this is getting really interesting, and I want to know what the answer to this question is. So, don't be discouraged if the question that your group comes up with is one that you're not initially too thrilled about. There's a good chance that you will get more and more excited about that question as time goes on. So just as an example of a question that I came up with here, just for the purpose of this presentation, is this question here. This is a question that I'm actually quite interested in. Does alcohol consumption affect the results of an oral glucose tolerance test? So if you're not familiar with an oral glucose tolerance test, this is a common clinical test for assessing whether someone is diabetic. Basically, you drink a solution of glucose, and then they take blood samples every so often thereafter, and they basically see, well, how long did it take for your body to kind of get rid of this glucose that you consumed from your blood plasma? How easily could that glucose be taken up into your tissues and things? And so if it's taking a very long time, that's probably because you are diabetic. And so the question of, does alcohol consumption affect this? Well, I think it's a really cool and relevant question, because if one imagines that a person shows up at a clinic and they're going to do an oral glucose tolerance test, and maybe they were drinking the night before or maybe even the morning of, we have to be wondering, okay, well, can we still do this test? If we do the test, will the results be valid or invalid? Yeah, I think it's an important kind of clinical piece of knowledge. So this is a question that I'm interested in. It's a question that feels to me like it would be a relevant question in a clinical setting. So once I have my question, what do I do next? Okay. And the thing you have to do next in the context of this BioC32 short communications assignment is you have to verify that this question you've come up with can be answered with HumMod. You have to keep in mind that you are not actually going to be doing this experiment on real people. You're going to be simulating your research question, your research experiment, using HumMod. Okay, and you've been introduced to HumMod already in the tutorials, and hopefully you're going to spend a little time diving in and playing with HumMod a little bit more on your own. But you really have to make sure that you can answer this question with HumMod that you've come up with. So here I'll just show you that for this question that I have come up with, I can see here that when I go to the lifestyle tab and then to drugs, there's an option for ethanol, and it brings me here. Allows me to have a person either drink a single alcoholic drink or kind of chronic alcohol consumption, have them drink many drinks every day. I can even see that it measures their blood alcohol concentration, so I could definitely give the person alcohol and see what effect it has. And then also here, if I go to interventions and tests, there's an oral glucose tolerance test, and so here I hit the little exclamation point and the person drinks a bunch of glucose in a solution, and then I didn't show it here, but you can also monitor their plasma glucose levels and basically see how long does it take for those levels to come back to the pre-test level. So I can definitely answer my question here on HumMod. I can set this person up to have a drink before, some length of time before they do the test, or I could model a chronic alcoholic who's drinking all the time and then is going for a test, make them take the test, see what happens. I definitely know that I can do this with HumMod. So make sure that you verify you can do this with HumMod. I'll mention a couple of things related to this. One is that the custom AI peer review program that I've built for students to be able to get some quick feedback on their submissions, it has been given a list of variables that HumMod can simulate, and it has been asked to kind of look at your research question and kind of get a general sense of whether it thinks it could be done with HumMod or not. It's not going to be perfect. It's kind of sometimes hard to kind of look at a list of variables and look at someone's research question and necessarily match things up perfectly. So definitely, I would still go through the manual check of making sure yourself that HumMod can actually do this. And if you are still uncertain, even after you've gone through the AI peer review and even after you've kind of manually checked what HumMod can do, if you still have any uncertainty about, hey, could I actually answer this question using HumMod, just send me a quick email or Discord message. And I know HumMod pretty well from having worked with it for quite some time now, and I can probably answer your question pretty quickly too. Okay, so once we know that we can answer the question with HumMod, really the next thing we then have to do is figure out, well, is this a novel question? Do we already know the answer to this question? Because we just came up with a question that we were interested in. Does science already know the answer to this question? Now, what's interesting to me is that the last time that I recorded this module video, which apparently was back in 2022, I was looking that up just a bit ago. In 2022, of course, when I recorded this video, what I would have advised you at this point in terms of figuring out if the answer to your question is already known or not is I would have said, well, you're going to have to go to Google Scholar, you're going to have to go to Web of Science, you're going to have to maybe search for things like alcohol consumption, glucose tolerance, or alcohol consumption, diabetes, or something to get a sense of whether we know, whether we know the answer to this question or not. And you can still do those things for sure, but now in the era of generative AI, one of the other options you have available is to go to your favorite generative AI platform. So I'm not saying that ChatGPT is my favorite, but ChatGPT 5 came out just a couple of days before I sat down to record this video for the year. So I thought I'll use ChatGPT 5. I put my question in. I just said, as you can see, does alcohol consumption affect the results of an oral glucose tolerance test? And of course it said, well, the short answer is yes. So right away that makes me think, okay, well, I haven't come up with a novel question. It's an interesting question to me, and I can again assert that it's a relevant question clinically speaking. But it seems like we might already know the answer. Now, I didn't just take it for granted. It said yes, and then just sort of stopped. I did go through and read what it had to say. And one of the really interesting things here, of course, is it did give me some links to research articles that weren't necessarily specifically about alcohol and glucose tolerance tests. Some of the links here were about alcohol consumption just on like plasma insulin levels, and some of it was on how alcohol consumption together with glucose consumption can cause hypoglycemia, as you can see. So although it's telling me yes, it can affect the glucose tolerance test, it didn't actually ever link me to any studies that directly show that that was the case. It was mostly linking me to studies that sort of hinted that it would make sense that alcohol would affect the oral glucose tolerance test because of these other known effects of alcohol on insulin or glucose levels or whatever. So a couple of things I guess to say here. One is make sure you actually click on these links, okay, especially the ones that are scientific journal links. Make sure that they exist, the articles exist, because we all know that generative AI is very good at hallucinating. Lots of times it'll give you links to studies that don't actually exist when you search for them. So make sure that the links that they are giving you are connecting you to real studies that actually exist. Read those studies over, at least their abstracts, to get a sense of do they actually have, is the information contained within those studies? Is it actually what the generative AI told me was in there or not? Because sometimes, again, it misinterprets things. So do a little exploration here and make sure that the links it's giving you, again, are good links that are giving you information that's consistent with what it's telling you. Like I said, in my case, when I read the papers, again, nothing was specifically about alcohol and oral glucose tolerance tests. So I could decide that I'm going to actually, do my short communication about does alcohol consumption affect oral glucose tolerance tests? And I can perhaps use some of these references here to say, well, we know that alcohol has this effect or that effect on glucose or insulin, and therefore it might affect a glucose tolerance test, and I can go and do that. The other thing I might do, though, is say, okay, well, it seems like it should based on the data that they're giving me here. So maybe what I'm going to do at this point is say, you know what, I think we already more or less know the answer to this question. I do the study just to kind of confirm it directly, since it doesn't seem any of the studies that it gave me confirmed it directly. But what I'm going to do next here is I'm going to think about, okay, number one, downloading these links that it gave me, downloading these papers, because I'm probably going to use them in the introduction to my short communication. Right, so I've already got these few research papers I can start with. But if I'm pretty convinced that the answer to my question is already known based on the information I'm getting here from AI, and I've confirmed it, I don't have to go back to the start and blow up everything I've done and say, okay, well, now we better come up with an entirely new question. Students tend to want to do that. They want to say, okay, well, let's go in a totally different direction. Let's ask about, does melatonin level affect your heart rate or something? Like, they just go in some totally different direction. But what I would suggest is don't blow things up completely. Like, you already are interested in alcohol and diabetes and oral glucose tolerance tests. Look and see if there's some way you can kind of nuance your question to come up with something more novel. So I'll give you a couple of examples of this. Here's a question that I've now come up with, which is the effect of alcohol on the oral glucose tolerance test different between males and females? And again, I can go back through the same process I just did. I could feed this question to ChatGPT and sort of see what it says. And maybe it'll say yes, and maybe it'll link me to papers, and then I have to kind of keep maybe nuancing things further. Maybe if it turns out we know the answer to this question, I might say, well, is the difference due to estrogen levels, for example? And if I keep kind of nuancing things, I'm going to eventually get to a question where ChatGPT is going to tell me, yeah, there probably isn't a lot of information here. This is going to be a good place for you to do a little bit of research. Okay. Here's another question I came up with. Does lisinopril affect the results of an oral glucose tolerance test? So here I basically said, okay, turns out we already know the effect that ethanol has or alcohol has, but what about other drugs? Lisinopril is another drug that's available on Hamad. It's a drug that is given for blood pressure regulation. I know, for example, that people who are obese tend to have blood pressure issues. People who are obese also tend to have diabetes. So there's a very good chance that someone could be on lisinopril and then they go for an oral glucose tolerance test. So, does the presence of that drug in their system affect the results of that test? Again, I'm going to have to go through the process of figuring out, do we already know the answer to this question or not? And if we do, again, I'm going to have to try and nuance things to kind of work my way towards something that we don't know the answer to. Okay? But that's just how I would kind of go about it. I would start with a question that I'm interested in. I would make sure I can do it in HumMod. I would start doing a little bit of research, whether it's through traditional routes like Google Scholar or whether it's through generative AI routes, to kind of figure out, do we know the answer to this question or not? If we don't, great. It's going to be the question that I use. And if we do, I have to start thinking about ways that we can nuance that question a little bit to get myself to something that is novel and unknown. Okay. Again, seems simple when you kind of talk about it here in a presentation, can be a little bit more challenging when you're actually doing it. And again, if you need a little bit of assistance with this, again, reach out to me. Email, Discord, grab me after class, office hours, all these different ways that we can interact. And I'm certainly happy to help your group kind of work their way towards a good question. Now, I just used the phrase good question here a second ago. So I want to talk about that next because, coming up with a research question is one thing, but coming up with a good research question is another. We want you to come up with good research questions. And so I'm going to introduce you here to what's called the finer criteria for a good research question. Basically, there's kind of 5 criteria that you should think about as you try to assess whether the research question you've come up with is a good one. So let me just walk you through this here. So F stands for feasible. So a good research question is a feasible research question, which basically means it's a research question that you could actually do. Now you'll notice that some of the things that they've listed here in terms of thinking about feasibility aren't necessarily relevant to the BioC32 short communications. It talks about adequate numbers of subjects. Well, again, you're not recruiting subjects, you're simulating the data through HumMod, so you can simulate as many subjects as you want on HumMod, so that's not a problem. The adequate technical expertise, well, again, you're not actually doing an experiment on HumMod, so it doesn't matter about technical expertise. Affordable in time and money. Again, you're not actually spending any money to run HumMod, so those first things aren't really relevant. The last one I would say is worth thinking about in the context of the BioC32 short communications and your use of HumMod. This idea of, is it manageable in scope? And the thing I would think about most here is that when you are actually simulating your research experiment on HumMod, think of HumMod as basically it's going through thousands and thousands and millions and maybe even billions and billions of mathematical calculations to kind of simulate the human body. And of course, how fast it can do that depends a bit on the processing speed. Well, depends a lot on the processing speed of your computer. So what I would suggest, I guess, is when you're planning out experiments in HumMod and when you're thinking about, is my research question a good one or not, I wouldn't do too many experiments where it's like, oh, we're going to simulate for a year or simulate for several years to see these major long-term effects. Because you'll probably find yourself sitting there staring at your laptop for hours waiting for HumMod to simulate through. So that's the one thing I would think about in terms of feasibility here is kind of plan out experiments that are maybe kind of shorter in duration, maybe think more in terms of days or weeks or months at most, and don't plan things that are, years and years worth of experiments. The I here in finer is for interesting. So, a good research question is one that, people would be intrigued by the answer. And it's interesting here because it says intrigues the investigator. So I was kind of getting at this earlier, like it's a good research question if you are excited to know what the answer to the question is. It's a good research question if you think other your peers, so maybe other students in the course, or maybe even me, if you think that they would be interested in what the answer is, then that's a good question. Or if the community at large would be interested in what the answer to this question is. So make sure that you're coming up with an interesting question, right? That somebody would actually want to know the answer to. Novel is critical, right? And here under novel, they say confirms, refutes, or extends previous findings. I would say that our goal here for BioC32 is not that you're designing experiments just to confirm or refute previous findings, but really to focus on the extension. Okay, so we don't want you saying, well, in 1999, somebody did a study where they showed that if you took lisinopril, it would affect your vitamin D levels, and we just wanted to run the same experiment on HuMMUD and see if we got the same results. We're going to reject those kinds of research questions. So we don't want you just confirming or refuting. There are definitely, this is an important part of the scientific process is repeating experiments and getting the same results, or refuting previous findings. I'm not discounting the importance of that in scientific research, but as far as BioC32 goes, we really want to focus you on coming up with questions that are going to be novel in terms of helping us to extend our knowledge and not just confirm or refute. Ethical next here. So again, this is not so important in the BioC32 short communications confines here, because you're not actually running your experiment with real human participants. So ethics is not necessarily a huge concern in terms of your research question. Generally, if you were doing human research, you'd want to make sure that whatever question you were going to come up with, you could actually do an experiment ethically with the human participants. As part of the short communications assignment, we are going to have you do an ethics review. It's one of the future modules that I'll go through with you. We are going to have you do an ethics review and just sort of assess whether your research would be ethical or not if you were going to do it on real human participants. But the ethics of your research question doesn't have to be something you think about here in BioC32, with one caveat. Okay, and that caveat is that we are not going to accept research questions where they are clearly inappropriately unethical. What do I mean by that? Well, if your research question, for example, was how much can I beat a guy up before he dies? And you say, oh, that's really relevant because if I'm a mobster or a gang member, or I don't know, I want to be able to just beat someone to the point where they might confess something to me before I kill them. We're not going to accept research questions that are clearly, ridiculously unethical. But if you're asking, hey, we want to do a question where we're going to induce a heart attack in our HuMMUD patient and see if the level of blood glucose affects how long they can survive, that's that we would accept. That's not something you could do in an actual research clinic, right? No one's going to sign up to say, yeah, give me a heart attack and let's see what happens. But we can do those kinds of unethical studies in HuMMUD. So hopefully you can see that distinction between an unethical study that we could not do in humans just because it'd be unethical to induce a heart attack, but we kind of can do it here in this simulated environment, and actually knowing how maybe your plasma glucose level affects your survivability in heart attacks is actually really clinically relevant. That's very different from a study where we're just trying to beat someone up to see how hard can we hit you before you die. So hopefully you can see the distinction between those two. Lastly, in trying to come up with a good research question, you want to be thinking about relevance. Right, and it says three things here. Is the question relevant to scientific knowledge? So will it help us to, will it help the scientific community to kind of push forward in terms of its knowledge and understanding of the universe? Is it relevant in a clinical or health policy context? So is it going to help us, help physicians, for example, to provide better care to their patients? Is it going to lead to substantial revision of health policy to, again, benefit patients in some way? And is it relevant to future research, right? Is it going to open the door to further research? So again, you really want to be kind of keeping these finer criteria in mind as you are trying to come up with your research question, and make sure that you're planning something that's, again, feasible, interesting, novel, ethical in the way that I talked about, and also relevant, because we're going to be considering those criteria as we evaluate your research questions. Excuse me. The last thing I wanted to mention here before I talk about the actual submission you're going to send to Quirkus is I want to really talk about something that I've noticed cropping up in a lot of student submissions over the years. The way that the scientific method is kind of laid out is you start with a question, of course, right, which is what we're talking about today. You start with a question. You might come up with some kind of hypothesis. What do I think the answer to this question is going to be? You then do the experiment and you get data, and then you basically assess what is the answer to my question, and was my answer consistent with my hypothesis or not. This is the way that the scientific process is meant to occur. What often happens in BioC32, I've discovered, is students will kind of do things in a strange order. They'll often run experiments and get results, and then they'll go back and they'll try to conform questions to the results that they got. And I think the reason they do this is because they're so worried that, well, what if I come up with a question and then I run the experiment and I get data and that data is very different than I expected? I'm going to lose marks if that happens, aren't I? And I want to emphasize right here, no, of course not, right? Excuse me, goodness. Of course not. You're not going to lose marks because you did an experiment and got results that were different from the results you expected. I mean, that is science, right? Many times in my life, I've done experiments and gotten results that I wasn't expecting. And what that means is it means that I don't quite fully understand what's going on, right? Not that I don't quite fully understand, but just science in general doesn't quite fully understand what's going on here. And it's an opportunity for me to now think, okay, here's the data I got, different than what I thought, but how can I make sense of this data, right? And again, that's an exciting part of science, right? Like getting a result that you weren't expecting should actually not be apprehensive. It shouldn't cause you, fear and anxiety. It should cause you joy and excitement that you now have an opportunity to kind of craft to kind of craft a story that can help to explain your data, maybe even do another experiment to see if this new idea you've come up with leads to the kind of predictions that you think it will. So I guess the point I'm trying to make here is make sure you're doing your experiments here, following the scientific method, that you're starting with just coming up with a question, and then as we flow through the modules, designing the experiment, executing the experiment, etc. Don't try to run things on HumMod and say, oh, I'm getting the data, here's the data I'm getting, how can I go back and write a question that'll, that data would make sense with. Let's make sure that we are flowing the scientific method in a way that it's supposed to flow. Okay, so the last thing I wanted to talk about here, and I'll wrap up this video, is what are we submitting for this module? So unlike Module 1, where all you had to do was listen to me talk for an hour and there was nothing to actually do, here, of course, you have a lot to do. So what are you submitting for this module? Well, you're submitting the introduction to your first short communications assignment. Okay, so you've probably read scientific papers, you've certainly written lab reports, I'm sure, in the past. You have a general sense of what an introduction is meant to do. I'll go through some of the details here in a second. But the first thing I'll say is that it should be approximately 500 words. So that gives you a bit of a length guideline. If it's significantly shorter or significantly longer, the TAs will likely flag it and ask you to revise and resubmit. In terms of what should I focus on when I'm writing my introduction, I want to direct your attention back to the finer criteria I was just talking about a moment ago. And you can see I've kind of faded out the F and the E here because in an introduction, we don't necessarily have to talk about the feasibility of the study. That would generally be something that we would emphasize more in the methods. And I've already emphasized that, ethics is not something we're going to have you really worry about in terms of coming up with good research questions with limitations that I already discussed. And certainly we are going to have you do an ethics review a little bit later on as part of one of the later modules. So really what I would say is focus on the INR in your introduction. Start with the N. Start with the novelty, right? So start your introduction really by telling us, here's what we already know that's kind of related to the research question you've come up with. Cite some papers for us that kind of prove that this is already known. And then that's going to gradually lead into, well, here's what we don't know. And that's going to lead into your research question, right? So you're kind of flowing your introduction from here's what we know about this general research area, here's what we don't know, and here's the particular research question that we're going to explore here in this paper. I do want to emphasize, as it says here, make sure your research question is written as a statement rather than as a question, right? People don't write research questions with question marks at the end. They write them as statements. So if I go back to my alcohol and oral glucose tolerance test, I'm not going to say, does alcohol affect the glucose tolerance test results? Question mark. I'm going to say something like, maybe I start my introduction by saying, we know that chronic alcoholics tend to have lower insulin levels, and we know that consuming sugar-rich alcoholic beverages leads to lower hypoglycemia or something. I might move into saying this leads us to wonder whether or not alcohol consumption affects a glucose tolerance test. It's not a question that I've written. It's a statement, ends with a period, but it's still a research question. It's still a statement of what we don't know. And then I would say end with the interesting and relevant, right? So talk to us about, after you've introduced your research question, talk to us about, well, why is it important that we get the answer to this question, right? How is the answer to this question going to benefit humanity? How is it going to help with health policy or to improve patient care? How is it going to further our scientific knowledge in important ways? Talk about that. Right, so that's kind of the general organization that I would recommend for your short communication introduction here for this module. I do want to emphasize, of course, citations. So make sure that you are, making reference to previous studies, especially when you're telling us about what's already known. Obviously, that's known and published somewhere, so there should be citations in particular in that part of the introduction. Make sure you've got both in-text citations and a reference list at the end of your short communication here. Think back to the first module where we talked about citations as you are doing that. And then once you have kind of written your introduction, here's what I want you to do first. Submit your work to the custom AI peer reviewer for BioC32. So this is linked on Quirkus. It's linked on Quirkus. Submit it there. And again, this is a new project for me. It's something I just built recently. And so I'm also very happy to get any feedback you might have for me on what you thought about this AI peer reviewer. But the reason we built it was twofold, really. One was to take some pressure off the TAs, right? Especially because we allow you to revise and resubmit your submissions. The TAs sometimes get a bit overwhelmed with okay, well, you're on your third or fourth kick at the can here of this module. We're getting overwhelmed by the volume of submissions. So the AI peer reviewer takes a little bit of pressure off the TAs, but also it allows for you to get some instantaneous feedback. Again, the AI peer reviewer knows exactly what we are asking you to do, so it's going to give you feedback that is customized to this course. Obviously, you could just submit your paper to ChatGPT and just say, hey, what do you think of this paper? And it will give you some feedback. But the AI peer reviewer knows exactly what we're looking for each module, and therefore tries to evaluate it in that specific context. So submit your work to the custom AI peer reviewer, read the feedback that you get, make any revisions that you think are worthwhile making, and then you'll submit your work to Quirkus thereafter, and the TA will then evaluate it. And I mentioned this in the syllabus, but I'll just talk about it here briefly. When the TAs evaluate your work, they're going to give it one of three possible outcomes. So either they're going to give it an unconditional approval, and you'll get a mark of 5 out of 5 for your module submission. This basically means they loved everything about what you did. There might have been some minor things here or there, but generally they really loved what you did. There's a conditional approval. So this basically means that your research question is fine. Okay, so you've got a good research question and you could move on to the next module, but maybe they had some problems with the other parts of your intro. Maybe there were problems with your citations. Maybe you didn't make it really clear why this is novel or relevant or interesting. So with a conditional approval, it means that you can either take the feedback you got, revise and resubmit, or you can say, you know what, 3 out of 5 is good enough. I'll move on to the next module and kind of get going. Okay, so you have an option with the conditional approval. The last outcome is rejection. So this is going to happen in cases where your research question is deemed to be a problem. So maybe it's a question that's unclear. Maybe it's a question that we know can't be done on HuntMod. Maybe it's a question where the TAs are like, yeah, we already know the answer to this question. We had one group a couple years ago who it was getting very late in the semester, so they were just desperate to submit anything, but they submitted a research question like, does epinephrine affect heart rate? Well, yes, we've known that epinephrine affects heart rate for over 100 years, so we're not going to approve that research question. So anyways, those are the 3 possible outcomes. And so, yeah, once you get an approval, you are free to move on to the next module. So module 3 in this case. If you get a conditional approval, you can either move on or you can go back and revise and resubmit. It's up to you. Part of that is going to be, if you get going on this earlier, you have more time for the revise and resubmit. So maybe you want to do that. But if it's starting to get later in the semester and you're thinking, oh, I might not get through all the modules, but I don't just get going, maybe then you just take the conditional approval and you move on. Okay, with that, I'm going to stop talking. So hopefully this has been a useful video in terms of helping give you some sense of how you can come up with a good research question. We're really interested to see the diversity and of the research questions that you come up with. Yeah, so take care. I'll see you in the next module video.